We wanted to give an explanation for the compressor inlet and diffuser system for the air turbo rocket engine. Recently we've developed, fabricated, and built a new inlet system consisting of an inlet face and a diffuser for the radial flow compressor on the air turbo rocket. And we wanted to show you some of the parts we've made. So air goes into the inlet through this front inlet, and as a radial compressor it goes in. It turns radially and is accelerated out radially, and then it makes one final turn axially so that it flows down axially out of the turbo machinery housing, and at the aft end of this section is the afterburner, where the air enters and mixes with the fuel from the turbine drive gas to mix and burn. But we wanted to show you this particular part, the front end, which is our new addition to the air turbo rocket system. So the inlet consists of a kind of a snout that connects to our inlet flow tube where we make airflow measurements, and it also creates a uniform flow at the face of the compressor. This component is welded to this front flange, which attaches to the body of the turbo machinery housing. Here you can see the compressor face. It consists of a kind of a standard turbocharger type compressor. It has 6 main blades and 6 splitter blades, you can see down in there. And if you can look closely down in there, you'll see the inlet to the diffuser section, which consists of these kind of wedge type sections that we'll see in a moment. As the air is accelerated off of the tip of the compressor, it enters those wedge type sections, flows radially outward where it is the area grows, increases in area, which slows the velocity down and converts the kinetic energy of the airflow into total pressure rise in the system. Let's look at a detail of the diffuser section of the compressor. This is our newly fabricated component for the air turbo rocket section. And it consists of these wedge-shaped flow passages in which the high velocity air coming off the compressor tip flows into these passages and then is diffused, or in other words, its high velocity is slowed and exchanged for rise in the total pressure of the airflow. The flow flows down these radial passages, and then it turns axially in this section of the diffuser and flows down between the two walls of the compressor housing. The flow then enters the combustor section of the air turbo rocket. After designing the diffuser section, the geometry consisting of computer CAD files were handed off to Streamline Automation, who used these files to generate the toolpaths for their automated CNC machining capability. And the diffuser was CNC machined out of a solid billet of 6061 T6 aluminum to create the diffuser that we see here. So we'll be looking forward to testing this in the subsequent testing of the ATR engine.